Hello everyone. Welcome to Earl's channel. Today we will talk about blue hydrogen, our future fuel. The world needs more energy than ever before. Which means we need a sustainable system that can meet these growing demands, whilst also addressing CO2 emissions and the overall impact on the environment. One possible solution is hydrogen, which has the potential to deliver sustainable, efficient and affordable energy at scale. However, it is expensive to transport. So how could we make it commercially viable to deliver this clean energy around the world? Now why we think about hydrogen. Hydrogen is not only the most abundant element in the universe. It could also play an essential role in tomorrow's energy mix, from fueling cars, trains, trucks and ships to generating electricity and heating buildings. That's because it's a colorless, clean fuel that emits only water when burnt or oxidized. Currently, around half of the world's industrial hydrogen comes from natural gas, methane, and is used for fertilizers, as well as in the iron, steel and space industries. However, the traditional method of extracting hydrogen from natural gas also creates around 10 tons of CO2 for every ton of hydrogen produced. Therefore, we needed to find a more sustainable way to produce it. Blue hydrogen, a key element of the circular carbon economy. For over a decade we have explored potential technologies to produce high-purity hydrogen from hydrocarbons, including thermo-neutral reforming and a catalyst for converting diesel into hydrogen. Our ultimate ambition was to create so-called blue hydrogen, extracting the valuable gas whilst also capturing all the CO2 emissions. When methane burns it creates hydrogen and CO2, but what makes blue hydrogen different is that we capture these CO2 emissions and either recycle, remove or reuse them. This all forms part of our vision for a circular carbon economy. Currently, we can successfully convert around 80–85% of the energy of the hydrocarbon into hydrogen fuel, and then use two innovative technologies to utilize the captured CO2. The first involves injecting it into one of our oil reservoirs for enhanced oil recovery, whilst the other takes the waste CO2 and converts it into chemicals like methanol for industrial use. Any additional CO2 can also be safely sequestered deep underground. Creating blue hydrogen was only half of the solution. The next problem we had to overcome was how to affordably store and deliver this revolutionary fuel to where it was needed. Hydrogen is a very light molecule. It can be liquefied, but that requires keeping it at a temperature of -254 degrees Celsius, which makes it very difficult and expensive to transport, particularly over long distances. The solution lay in converting the hydrogen into a chemical compound which is already widely traded around the world, ammonia. Compared to hydrogen, liquefied ammonia is far more convenient, practical and cost-effective to transport, in terms of both the required temperature and pressure conditions. Once the blue ammonia reaches its destination, it can be converted back into blue hydrogen, or used directly as a fuel for gas turbines for cleaner power generation. In 2020, we successfully completed one of our most ambitious pilot projects to date, a supply network demonstration covering the complete hydrocarbon value chain in partnership with SABIC and the Institute of Energy Economics Japan, IEEJ. The fruits of this unique collaboration came in August 2020, when we successfully shipped 40 tons of high-grade blue ammonia to Japan. The blue ammonia itself was transported to 3 facilities in Japan, where 20% ammonia was successfully co-fired with coal, and the same ratio with natural gas, in existing power stations. This pilot is one of many initiatives that will help Japan realize its ultimate ambition of becoming a decarbonized society, and according to the IEEJ, about 10% of power in Japan could one day be generated by blue ammonia. Hydrogen and fuel cell technologies also have huge potential as a sustainable transport fuel for the future. In 2019, Aramco established the first hydrogen fueling station in Saudi Arabia, whilst countries such as Japan, China and South Korea are also investing in hydrogen charging stations and infrastructures. This increasing demand for hydrogen helps demonstrate the importance of our ability to transport it around the globe at considerably lower cost. There are still several challenges ahead, such as developing ways to convert a higher percentage of the hydrocarbon energy into hydrogen, and working together with our partners around the world to establish wider infrastructures and supply chains for power generation and hydrogen-powered vehicles. However, it's clear that converting natural gas into blue hydrogen could be key to generating affordable, reliable and sustainable cleaner energy for everyone.